So welcome back to Statistic 1, Chapter 2, Representing and Interpreting Data, topic Cumulative Frequency Curve. So what's it mean by a cumulative frequency curve is obtained by plotting the upper boundary of each class in a dataset against the cumulative frequency. The points are joined by a smooth curve. And here, in order to understand what is a cumulative frequency, I have an example. Joe wants to investigate the cost of textbook in a bookstore, and Joe takes a large sample of 470 textbooks, and the results are summarized in a table. So, for example, the book week costs from 0 to 10. There are 13 books, and like the others, the book week costs from $45 to $50. We have 6 books. So in here we can see that there are 13 of them which cost from 0 to 10, but we have 10 to 15, we have 55 of them. So what if we find the upper boundary? So how many books cost less than 15? So it will be this one plus this one, because both of them are less than 15. So let's take 13 but with 53, we will have the one that costs less than 15 is 66. So how many books will cost less than 20? So less than 20 mean 3 of them. All 3 of them will cost less than 20. So we take 66, which is the cost less than 15, plus the cost of 15 to 20. We have 66 plus 97. We have 163. So and so on. So cumulative frequency. Cumulative means running total. So when you add them up, the last value will be the total sample that you took before. Here. So if the cost of the book is less than 50, then there will be 470 textbooks. So we are looking for the upper boundary of each one. We are not we do not work them in separate group. We work them in the boundary, the upper boundary of each class. So how we construct a cumulative frequency curve. First, we have a straight line, the vertical axis, and the straight line for the y-axis. Here is our measurement. In this case, we'll see it is cost, and you have to remember the unit cost. And this one, always cumulative frequency. Relative frequency. The x-axis. Because our maximum numbers is 470, so I will choose my maximum here is 500. So we'll make them into scale. 200, 300, 400. So the first one, we check the upper boundary. We look at this one. So the one that costs less than 10 will be 13. So I will take another color to make it clearer. Here, the one that costs less than 10. Here, write 10 down here. 10. One that costs like 20. Here's 15. 25, 30, 35, 40, 45, and 50 down here. So for the one with cost less than 10, we have 13 of them, so I put an X in here. Cost less than 15, we have 66, so which is this high. Cost less than 20, we have 163. This one here, 163. Cost less than 25, we have 308. It's in here. We put an X. With 30, less than 30, we have 389, which is around here. Less than 35, 429. Less than 40, 452. and put less than 45, 464, and put less than 50, 470 up here, 470. So when we plot all of these points, then we connect them by in a smooth curve. We use a smooth curve as possible to connect them here. So we have a cumulative frequency curve. Cumulative frequency curve. This cumulative frequency curve is the accurate version of the cumulative frequency curve I created before. So here I can be from this curve I can be able to find my lower quartiles, my upper quartiles, and my medians. So first we have to find the locations of my lower quartile, upper medians, and upper quartiles. So the location of my lower quartile is 117.5. Location of my median 235, and the location of my upper quartile is 352.5. Because the total sample is 470 multiplied by 1/4, we have this. Divided by 2, we have this, and multiplied by 3/4, we have this one. They are the location. So from here, look at here. So I'm going to work with the lower quartile first. Here, my lower quartile, the position is 117.5, which is nearly here. Read off from graph. You see it's around $18. So for my medians, 235 in here, read off from graph. I have equal to $22.5. So for my upper quartile, which is 352.5, can read off from graph again, and I can check numbers of 27 from here, $27. So from here we can work out the interquartile range. IQR equal to Q3 minus Q1. 27 minus 18 is $9. So next, in reality, what if I have a question? If I have only $16, so how many books can I buy from this bookstore? So we can work the other way around. Let's see. Here I have my $16 here, $16 here. So the number of books I can buy in this bookstore is around here. So I can find that I can buy 80 books from the bookstore, because for 16 we have kind of 80 here, so it's kind of an estimation whether what if I want to find a number of book which is greater than $32. So from here, from 32, I read up from 32, this line, upward, up to this point here. So then I will read from here. So from the graph, I can see that there are 410 book, which is smaller than $22, smaller or equal to $22. So the numbers of book which is greater than $22 is equal to 470 minus by 410, which is 60 book. So it's really easy to work both ways. From the graph, we can estimate and read off from the graph. It's really the cumulative frequency curve is really important. So one notice for you guys is that we plot from the upper quartile, as I told you before. Here's 35, 25. So the plot makes it the crossing here. You see the cross? Now we don't take the middle value like from 15 to 20. We will take 20 to be the one that we will use to plot the graph. We don't take 17.5 to represent our class. We take 20 because we are working on the upper boundary. So we take 20. That's one notice for you guys. And if we draw a graph, we should draw from 0 and connects to all the points to make a curve as smooth as possible, like this one.